Hello, this is Professor Denholtz, and I'm going to be reviewing problem 2 of Lab 1. It looks just like this. And there's a bunch of things going on here. We're actually going to do this all with lines. Now, we do have given that we can use the trim command. I'm actually not going to do that because I think we can demonstrate this best just with the line command. But I'm briefly going to show you how the trim command works. Let's say that you have a bunch of lines like this, and you want to cut them all at a certain plane. So let's say I want to get rid of this and this, this and this, everything that's to the upper right of this line. Well, the trim command would be very handy. So tr. The trick with the trim command is you want to select the cutting line first, not the line that you cut. So the cutting line is over here. So I'm going to click that and hit enter. And then the lines I want to cut, I cut just by clicking on them. And that's the trim command. We're actually going to see this later in the semester, but I did just want to demo it because it's one way that you can also use to make a drawing like this. That being said, in my opinion, it's much easier to draw it simply using lines. Now, the first thing is that in the previous problem, we had coordinates. Here we actually have the length of different edges, and they're given to us with dimensions. Now, this is usually how you see an object, and for that reason, I'm going to use the dynamic input, which I chose not to use previously. And it's going to make this drawing considerably faster than if we were to calculate all the different coordinates and make a drawing that way. So first thing I'm going to do is I'm going to click this. This is a plus with a little bar. It's the dynamic input button. When you click it, it's turned on, so it has a blue background. If you do not see this in the bar that's at the bottom of the screen, click these three lines that are horizontal and parallel that says customization, and go up to dynamic input and make sure that there is a check next to it. That's going to make it appear down here. Now the next thing I'm going to do is I'm going to turn on ortho mode. Now, ortho mode basically just means that everything is perpendicular, orthographic, vertical, horizontal, that's it. And so my mouse, the lines I make, the features I use, they're restricted to being either vertical or horizontal. And with a piece like this, that's actually perfect. That's exactly what we want. And it's going to allow us to make these drawings rather quickly. So I'm actually going to start over here. So I know that if I click here, I'm going to want to go 0.75 down. And then we could see 0.38 to the right. So let's just start with that. Now, because there's no coordinate system, I can actually choose anywhere to start. So I'm just going to start somewhere in the upper left hand of my drawing. I'm going to click, and then I'm going to move my mouse down. And you could see that the line begins to move downwards. If I have my mouse closer to the right, the line goes to the right. Same thing with up and left. But we're starting over here in this corner, and we're going to move this way around the object. So we're going to go counterclockwise around the object. So let's start by moving the mouse down, and I'm going to type in 0.75 and hit enter. Now that's the exact length that we wanted. Now, because we move to the right by 0.38, I'm going to move my mouse to the right, and I'm going to type in 0.38. And we know that the third line we want to draw is down. Now, one thing I would note is we actually don't know how far down it goes. So here, it's not dimensioned. Now we can look across. We know that these lines are at the same height. They're both 0.75 from the top edge. But this, to me, looks lower than this corner. And so we have to actually figure out how long this length is. We don't know. And so usually if a dimension isn't given, there is an obvious way to figure it out. And so we have to figure out how to determine what this length is. Now, what I would note is that this top edge and this bottom edge are both parallel. And so that means the vertical distance is going to be the same whether we're looking at the vertical distance from here to here as it is from here to here. And so the total vertical distance is going to be the sum of this 0.75, which is this line, this 1.25, which is this line, and this zero point 0.5 over here, which is this line. So let's pull up the calculator, add them together, and we get 0.75 plus 1.25 plus 0.5. And that means the total length from this edge to this edge is 2.5. Now, we're given the length of this line. We're not given the length of this line. We are given the length of this line, and we are given the length of this line. So there's only one known vertical length here, and so we can subtract this length, and this length to get this length. So let's do that. 2.5 minus 0.75 minus 0.5 minus 0.25. There you have it. That means that this length over here is equal to 1. So now we want to go downwards by 1. So we type in 1 and hit enter. Then we could see from here we're going to the left by 1. So 1, enter. Then we're going down by 0.5. So we move the mouse down, type in 0.5, enter. Then we're going to the right by 1. So 1, enter. Then we're going down by 0.25, to the right by 1.75, up by 0.5, right by 0.5, up by 1.25. And here we've hit another unknown value. So we're actually not given this length. And we actually can't have an easy way to determine it mathematically. However, we can actually see here that there's a 2x next to the 0.38 representing this length. Now that 2x tells us that the 0.38 repeats. Now usually 2x is going to be used for symmetry. Now these aren't exactly symmetric, but I can see that they're at the same height. They are appear to be about the same length, and this one is missing, and this one has a 2x. So it's enough information for me to infer that this length is going to be 0.38. So let's do that. So 0.38. Then we know we're going up by 0.75. And then it doesn't matter what the length is here. We just want to connect back to our starting point. And then I just pan it with the scroll wheel. We can see here that this is our object. This is exactly what we have here.